Alright, so I'm working through this problem here, which reads a 0.15 kilogram baseball is thrown and moving at a speed of 45 meters per second as it crosses the plate and strikes a 0.25 kilogram catcher's mitt, which is originally at rest. So I'm going to redraw a picture here, but here's the baseball, which I'll label with a B, going to the right. And it's going to go hit the mitt, and I'm just going to make the mitt kind of look like a hand. Alright, so that's supposed to be a hand, and I'll label that with an M for the mitt. Okay? Or actually I'm going to use G for glove, because M is mass. So we have the mass of the ball, which is 0.15. 0.25 is the mass of the glove, or the mitt. And then 45 meters per second is the initial velocity of the ball. So that's how fast it's moving in the start. So this is kind of the before picture, or initial. After the ball hits the glove, it gets kind of caught in the glove, so they are now stuck together. Okay, and they're going to move together with some common speed. So the ball should slow down, the mitt should speed up, and they're going to move together to the right because the original momentum of the situation was to the right, and afterwards it would be to the right as well. So for this first part, we're going to use conservation of momentum. So the total momentum initial should equal the total momentum final. So initially, we have the ball's initial momentum plus the glove's initial momentum should equal the ball's plus the glove's final momentum, because they stick together here. This is an inelastic collision, or technically completely or perfectly inelastic, but it's definitely inelastic. All right. The glove is not moving in the beginning, so the velocity is 0 here. So we just have the mass of the ball and the initial velocity of the ball should equal the masses put together with the ball and the glove, and then the final velocity of the ball and the glove final. Going through the math, it'd be 0.1 times 45 equals 0.15 plus 0.25, and then VB and G together, their final one. All right. So just doing the math on my calculator here, 0.15 times 45 is 6.75 for the total momentum, and 0.15 plus 0.25 is 0.4. Okay. We need to solve for the final velocity, so we're going to divide by 0.4 on both sides. And you end up with the final velocity of the ball and glove together to be 6.75 divided by 0.4, which is 16.875. That would be meters per second. It's positive. The positive indicates the direction of the motion, which is to the right. So we've determined the velocity of the ball / catcher's mitt immediately after the collision. So this is the work for this part. Then we're going to fill in the table for before and after. We've done some of the work already. So this momentum in the beginning is all for the ball, so that's the pre or before collision momentum would be the 6.75. The catcher's mitt is not moving. When we add those together, we get 6.75. This is positive going to the right, so the total momentum is going to the right. Afterwards, we could use conservation of momentum, which means that the initial or total momentum in the beginning should equal the final momentum at the end. So if we have 6.75 in the beginning for the total, we have 6.75 for the final at the end. Again, so those are equal. If they're equal, there's no change, so the change of momentum total would be 0. We can use the individual momentums to figure out the pieces. So for the momentum of the ball final, that would be the mass of the ball times the velocity of the ball final. So it'd be the mass of the ball, which is 0.15, times the velocity of the ball, which is the same as the velocity of the glove at the end, which is the 16.875. So 0.15 times 16.875 is 2.53125. I'm going to write out all the numbers because they're going to be useful. So it's still going to the right. It's 2.53125. If we don't write out the numbers, you might round a little bit, and it might change the answer and make it so it looks like it doesn't conserve, but it actually does. For the glove, we're going to do the same kind of work. So the momentum of the glove would be the mass of the glove times the velocity of the glove after the collision. So that's going to be the mass of the glove, which is 0.25, times the velocity, which is still that 16.875 because they move together. So 16.875 times 0.25 is 4.21875. If you wanted to check your work, if you add these two numbers together, you should get 6.75. So I'm going to do that real quick. And that worked out. If we didn't go all those digits, then this number might be slightly off compared to the initial and final, and I don't want that to happen, so I'm just keeping all the digits there. To find the change in momentum, again, change in momentum is just equal to the final minus the initial. So if we wanted it for the ball, it'd be the final ball momentum minus the initial, so it'd be 2.53125 minus 6.75. So you got to put it in my number calculator, 2.53125 minus 6.75 is a negative 4.21875. And that should make sense because that change of momentum should be the same magnitude but opposite direction to the momentum of the glove. So this would be the final glove momentum minus the initial glove momentum. We said the initial glove momentum is 0 and the final is 4.1875, and that's positive. So that minus 0 will get us the same number, the 4.1875, and it's positive. Again, if you wanted to check it, the way it should work out, if you add these columns, the positive and the negatives cancel out and you get left with 0, which makes you happy because you know you did it right. So there's the answers to that problem. For all of these momentums, it's measured in kilograms meters per second or Newton seconds. So that's just something you should be aware of. So all of these answers in this chart, they're all kilograms meters per second for every single one of these boxes. All right, have a good one.